Are we live? Hello, hello, hi everyone. So I think yes, we are live. And hi everyone, my name is Karan Mashru, and at present I'm an associate mentor at GeeksforGeeks. In today's live stream, we will be discussing the solutions of weekly coding contest 125. Okay, let us just wait for 1 minute more so that more people can join, and then we'll begin. Till that time, you can like the video and let me know in the comments how many you were able to solve out of 4 questions. Also, am I properly audible? Just confirm in the comments. 3. Okay, great. 3. Okay. Yes. Okay. Thank you. Okay. So it's 8:32. Let's begin at 8:33. Okay. Okay, Deepak. Thank you for confirming. Fourth question समझा दो. Okay, Ravi, sure. We'll solve the fourth question as well. But let us first quickly finish the first three, right? And then at the end we'll see question four. Okay. We'll give a good amount of time in question four. Please talk in English only while explaining. Don't switch to Hindi. I think I usually speak in English only. Okay. Okay. I think let us begin. More people will join because the starting first few questions are quite easy. So we can start with that. Till that time, more people will join. Okay. Uh, is my screen visible? Okay. I think my screen is visible. Let's start with the first question. Okay. Great. So let's start with the first question, built adjacency list. This was quite a simple question. What does it say? Given V, E and edges representing number of vertices, number of edges and edge description of bidirectional graph. Your task is to build the adjacency list for each vertex of the given graph. Edges I equals to UV means there exists a bidirectional edge between U and V. Okay. So what does this say in the input? If we talk about the first question, so we are given V, that is the total number of vertices of the graph, capital E, that is the total number of edges in the graph, and a 2D array edges in which if the ith element is u comma v, it means there is a bidirectional edge between node number u and node number v. Okay. This is an undirected graph, so the edge will be like this, and using these edges we need to build a adjacency list for the graph. Now what is a adjacency list? In adjacency list, what we do is, corresponding to each index, we store the nodes which are connected to that vertex. Okay. So for example, if I have a graph 1 2 3 4, okay, and let's say 5. So here if I make a adjacency list for this graph, then in the adjacency list at index 1 I will have 2, because only 2 is connected to 1. In the adjacency list of 2 I will have 1 3 and 4, because there is a edge between 2 1 2 3 and 2 4. Similarly, in the adjacency list of 3 I will have 2 and 3, sorry, 2 and 5, because 3 is connected to 2 and 3 is connected to 5. In the adjacency list 4, at index 4 I will have 2, because 4 is connected to only 2, and in the adjacency list of 5 I will have 3. Okay. So in this way we want to form the adjacency list. So basically what we can do is, we can make a adjacency list of size v, and for all the edges what I can do, if there is a edge, if edges of I, if the ith element is uv, then I can say adjacency list of u dot add or push back, I can say v, because there is a bidirectional edge between u and v. So at youth index adjacency list v will be there, and also in the adjacency list of v I need to add u, because there is also edge between from u to v, right? So what I can do, if we read the question further, note there can be self edges, there can be multiple edges which have to be ignored. The graph may be disjoint. Adjacency list of each vertex should be sorted in increasing order. Okay, so we want the adjacency list in increasing order, and it says that there can be self edges and there may be multiple edges which have to be ignored. So what is the meaning of self edge? If there is a edge from 2 to 2, this is called self edge. Okay, so in this case what we will do, in the adjacency list of 2 we will simply add 2. Okay, also it is said that multiple edges are to be ignored. So let's say if there is a edge between 3 to 5, if there are 3 edges between 3 to 5, only one edge will be considered. Okay, so in the adjacency list of 3, 5 will come only once, and in the adjacency list of 5, 3 will come only once. So how can we do this? We can simply short the edges first of all. Okay, now why am I telling to short the edges? Because here it is said that uh, if there are multiple edges they are to be ignored. So if there are multiple edges between same two nodes, we need to consider only one edge. Okay, that's why I need to short this. Also, while before shorting, what you need to do is, for all the edges uv, either make u is less than v or make v is less than u. Why? Because in the edges one pair might be 1 0 and one pair might be 0 1. Now both of them are same. Okay, and if you short them they will not be together. So for first of all, for all the edges, what we will do, we will make u less than v, then we will short all the edges, and then if there are multiple edges coming again and again, we will consider it only once. Okay, I hope the concept is clear. Let us go to the implementation part. So let me take the submission directly so that we can save time. So what I have done is, see, I have taken a 2D array adjacency list because I want to return a 2D array. Okay, and it is of size v because there are v number of vertices. Then first of all, for all the edges, if edges of I0 is greater than edges of I1, okay, so let us consider this is u, this is v. So if u is greater than v, I will swap them. So for all the edges, u is less than v. Okay, so what will it help us in? Similar edges, same edges will come together. Okay, so then I'll short the edges, and then what I'm saying, for I equals to 0, I less than e, j equals to I, why I is less than e, and edges of I0 equals to edges of J0 and edges of I1 equal to edges of J1 I plus plus. Now why am I doing that? See, I have shorted the edges. Okay, so all the edges will be, which will be same, they will come together. So let us say I have some edges 0 1 0 1 0 1 0 1, then I have 1 2 1 2, then I have 1 3, then I have 2 3. Okay, now these are multiple edges, I need to consider only once. So what I have done is, I have said, okay, let j be equal to I, and until my age is repeating, keep incrementing I. So I will come here, I will come here, and I will come here, and I will come here. Now this and these are different. Okay, so now I can skip all this, I can just add this age to my answer and then start from here. Okay, so that's why I have done that, because since I have shorted the edges, similar edges will come together. So while I is less than e and u of ith index, that is the age I0 is equal to age J0, and age I1 is equals to age J1, until same age is coming, keep on incrementing the iterator. Then simply add the jth age in the adjacency list. Okay, now here also I have if condition. Why? Because if my age is, let's say, 2 3, then in the adjacency list of 2 I will add 3, and in the adjacency list of 3 I will add 2. But if I have 2 2, I will simply add 2 in the adjacency list of 2. I will not add 2 2 times. Okay, so in order to avoid the repetition, if ages of j0 is equals to ages of j1, if there is a self age, then adjacency list of ages of j0 push back ages of j1. Okay, So I am in the edges of J0 in that index of adjacency list. I am pushing this vertex. Okay. And if it is not self loop, both the vertices are different, then in the adjacency list of index edges of J0, push back edges of J1, and in the adjacency list of J1 index, push back edges of J0. In this way, I will form the adjacency list and I can submit it. I hope this is clear. Is this clear? Shall we move on to the next question? I want to learn advanced Python of DSA. Can you give me course of Python with DSA? Definitely, there are also free resources available on the internet. You can consider watching Python in one video or something like that, so that you have a little bit of grip on Python, and then you can start learning DSA. Or else, if you are looking for a paid course, or you can also look at the self-paced DSA course with Python of Geeks4Geeks. Okay, you will get it on the website. Okay, so is this clear? Shall we move on to the next question, everyone? One more yes, please. Also, there are 22 people in the stream. Please like the stream. Okay, Deepak, thank you. So let's move on to the next question, that is small sum. So what does this basically say is, I'll tell you this question in a easy manner first, and then we'll go through the description. So in the second question, basically we are given an array which has n number of elements, and we are also given an integer k. Okay. So what we need to do is, for all the indexes I, where array of I is less than array of I plus 1, I will add to my answer that complete value. Answer is equal to answer plus array of I. And if this is not the case, if array of I is greater than equal to array of I plus 1, then, so if this is the condition, then we have to do this. Else what we need to do, else we will add to our answer plus array of I modulo k value. Okay, so this is simply what we need to do, and we need to return answer. Also, two things which we need to take care of is, we need to return answer modulo mod, and mod value is 10 to the power 9 plus 7. So after doing addition, at every step we will apply mod, and we need to consider the array in circular fashion. So for all I equals to 0 to n minus 2, we can check if array of I is less than array of I plus 1, right? And for I equals to n minus 1, we need to check the condition if array of I, that is array of n minus 1, is less than array of 0. Okay, we need to consider the array in circular fashion. Okay, to check this condition. That is simply what is asked in the question. So if we look further, given an array ARR and an integer k, your task is to find small sum of given array. Small sum is obtained by adding all the elements of the array in the following manner. So we want to find small sum. How can we obtain small sum? It is given. An element AI is added as it is if AI is less than A of I plus 1. So if AI is less than A of I plus 1, add AI as it is. Otherwise, A of I modulo k. So if AI is not less than A of I plus 1, then add A of I modulo k to the answer, where I ranges from 0 to n minus 1. Consider the indexing of the array in circular manner. That means if the size of the array is 2, then array 1 will be compared to array 0. Okay, so that is what I said, that we need to consider the array in circular manner, and we need to return answer modulo 10 to the power 9 plus 7. Okay, simple. Let's take the code. So basically I have taken one integer, answer equal to 0, n equals to array size, some ij iterator variables. Let me zoom in a bit. Okay, and I have taken long mod equals to 10 to the power 9 plus 7, and then for all the indexes from 0 to n minus 1, if array of I is less than array of I plus 1 modulo n. Now why am I applying modulo n? So when I will be equal to n minus 1, I plus 1 will be equal to n, and n modulo n will be equal to 0, so that it fulfills the circular condition. So if array of I is less than array of I plus 1 modulo n, simply add to the answer array of I, else add to the answer array of I modulo k. And at every step, don't forget to take modulo mod, and then we will return the answer. Okay. So this problem is solved successfully. Hey, are the problems on GFG contest listed in practice session? I'm not sure about that. So is this clear? Please explain 21. Line number 21. Okay. So basically, see, what they have said, that if array of I is less than array of I plus 1, in that case we will add to our answer array of I, right? Else we will add to our answer array of I modulo k. Is this clear? Now suppose, let's say my n is 5, number of elements is 5, so my indexes will be 0, 1, 2, 3 and 4. Now for 0th index, I will be 0 and I plus 1 will be 1. So I will check this condition, 0 and 1, right? When I will be equals to 1, my I plus 1 will be equals to 2. I am talking about checking this condition, okay? When I will be equal to 2, my I plus 1 will be equal to 3. When my I will be equal to 3, my I plus 1 will be equal to 4. When my I will be equal to 4, I do not have any next element here. But what we are saying is we need to assume the array to be circular. So what does that mean? 0, 1, 2, 3, 4 and 0. We need to consider it in this circular fashion. Okay, so after 0 there is 1 index, after 1 there is 2 index, after 2 there is 3 index, after 3 there is 4 index, and after 4 there is 0 index. So here my I plus 1 which I have to put in this condition is 0. So what I said, I am taking I plus 1 modulo n. So here I plus 1 will be 5 because I is 4, and modulo n. N is what? 5. There are 5 elements. So 5 modulo 5 is what? 0. So in order to satisfy this condition, I am taking modulo n. It is especially used for the last element. For other elements, it will not have effect. You can cross check. If my I is equals to 1, my I plus 1 modulo n will be equal to I plus 1 is 2. 2 modulo 5 is 2 only, right? So for this pair, this pair, this pair and this pair, it will not have effect. But for 4 and 0, when my I will be equal to 4, my I plus 1 modulo n will be equal to 5 modulo 5, which will be equal to 0. Okay, so the next element after 4 to be considered is 0. Now is it clear? That's why I am taking modulo n. Okay, great. So let's move on to the next question. 10 की power 9 plus 7 fit in integer. Why do you take long for any reason? See, what happens is definitely 10 की power 9 plus 7 fits in integer, but if you look at here it will first answer plus array of I it will do, and then it will take modulo mod. Now if answer plus array of I exceeds the range of the integer, it might get overflow. Okay, so just to be on a safer side, I have taken long. Okay, it might be possible that even if you take int, it will pass. Okay, so that's why I have in fact I usually also take long here. Okay, okay, so you are asking about this, then here definitely I can take int. Okay, here there is no meaning of taking long, but usually for answer variable you should take long, because the summation of both of them might get exceeded. Okay, in that case having array also in the long format may be good. So just to be on a safer side, I usually take long in all the cases, or long. Okay, there is no other reason. So let's move on to the third case, number of unique flavors of candies. Okay, so what does this question say? Geek has an integer array flavors having n candies. where flavor I represents the flavor of the ith candy. Okay. Geek wants to share K candies with the winner of a contest. Okay. He wants to share any K consecutive candies from the array, but wants to keep as many flavors of candies as possible. Okay. Return the maximum number of unique flavors of candy Geek can have after sharing K candies with the winner contest winner. Okay, great. So what does this question say? If we look at the third question, what does it say? Suppose it has n candies. Okay, Geek has n candies with him. Okay, and it also has a flavor array where a flavor of I denotes the flavor value. Let's say it is 5. So ith candy is of fifth flavor. Okay, so that is basically what it is denoting. Okay, if we look here, okay, it has a candies array, not flavor array. Okay, the name of the array is candies. So candies of I is equals to 5, then it means that the ith candy is of fifth flavor. Okay, now there is a contest and there is a winner of the contest. Geek wants to give the winner K candies from the N candies. Okay. But Geek only wants to give K consecutive candies to the winner. Okay. K consecutive candies to the winner. Okay. So it might be first K consecutive candies. It might be this consecutive K candies. It might be this K consecutive candies. It might be this K consecutive candies. It might be this K consecutive candies, but he wants to give K consecutive candies in a fashion such that he keeps maximum number of unique flavors of candies. Okay, remember here it is not said that he want to give maximum number of unique flavors of candies. He wants to give K candies in such a way that he himself keeps maximum number of unique flavor candies. Okay, so what we can do here is, see, let me take an example. Okay, so let's say K is 3 and N is 5. Okay, so let us take 1, 2, 2, 2 and 2. Okay, let us say this. Suppose the or let us take this as 1. Okay, so suppose the winner is given the first 3 candies. So in that case there are 1 and 2 flavored candies remaining with the Geek. That is 2 number of unique candies. If the winner is given these 3 candies, then the Geek will be remained with the candies 1 and 1, which is only one unique flavored candy. If these 3 candies are given, in that case also Geek will have first 2 candies having flavored 1 and 2, and there will be 2 unique flavor candies with him. So 2 is the maximum possible number of unique flavor candies which the Geek can keep with him after giving K candies to the winner. Now the point which I'm trying to make here is, first thing is that it might be possible that a flavor candy might be with the Geek as well as with the winner. That is no issue. Okay, if a flavor candy is with the winner, that does not necessarily mean that that flavor candy is not with the Geek. Here if I give the first 3 candies to the winner, here it has flavors 1 and 2. Even then Geek has flavors 1 and 2 with him. Okay, so it does not mean that the winner will not have it. We want to see that the winner has the maximum unique number of candies. Okay, after giving to the winner any K consecutive candies. In the second case, winner is having 2 candies, but both of them are of flavor 1. So the number of unique candies is 1. And in the third case also the number of unique candies is 2. So the maximum answer is 2. So what we can do is, see, what I can do is, let's say I have an array. Okay, so this is my array. Okay, so what I'll do is, I'll take one counter. Okay, let's say counter of, let's say, size n. Okay, where count of I will denote the count of I flavor candies. Okay, So basically, if my array is 1, 2, 2, 2, 1, my count of 2 will be equal to 3. Means candies having flavor value 2 are 3. My count of 1 will be 2. Means candies having flavor value 1 will be 2. Is this clear? First, let me know. Is this count clear? Okay, great. So now what I can do is, see, I can, okay, thank you. So what I can do is I can consider the first k candies and decrease their count. Now why am I decreasing their count? Because see, I want the total unique flavor of candies with the geek after giving it to the winner. So if I am giving away this k number of candies to the winner, these are the candies which are remaining with the geek. I want the unique count of candies in this, not the candies which I am giving away. So I will decrease the count of these candies, and if the count of any candy, if the count of I goes to 0, it means that now this there is no ith flavor candy with the geek remaining if I give away these k candies to the winner. Are you getting my point? For example, if I have 2, 2, 2, 1, and 3, now here my count of 2 will be 3, count of 1 will be 1, and my count of 3 will be 1. Suppose my k is 3. Suppose I decide to give away the first 3 candies, so I need to decrease their count. So if the so my count of 2 will be reduced by minus 1 3 times, because there are 3 candies of flavor 2. So my count of 2 will become 0. What does this denote? Other than these k candies, there is no candy with flavor I. Are you getting my point? So the number of unique flavored candies, let me call it with the variable total, with the geek decreases. So I can say total minus minus. Okay. If I am talking about these k consecutive candies, that is 2, 2, 1, then if I decrease the count respectively, then my count of 1 will become 0, my count of 2 will become 1, and my count of 3 will also become 1. What does this denote? Other than this k candies, there is one candy with flavor 2, there is one candy with flavor 3, and there are no candies with flavor 1. Are you getting my point? So now what I can do is, first of all, I can count the count array, okay, and count the total number of unique candies. Now how will I count the total number of unique candies? So let us say I moved over the array candies, and I said count of candies of I plus plus. Okay, now candies of I will denote the flavor number. Let's say it is 2, so count of 2 plus plus. In that way it will go. Whenever, if count of candies of I, if count of candies of I is equals to 1, at that time I can say total plus plus. What does total denote? The number of unique candies with the geek. Okay, so count of candies of I equals to 1, then total plus plus. Why? See, if I am saying 1, 2, 2, 1, okay, these are the candy flavors. First time when I will do count of 1 plus plus, it will become how much? 1. It means that the flavor candy with flavor 1 is encountered for the first time, so the number of unique candies increases. Next I'll go to 2, again my count of 2 will become how much? 2, sorry, 1. It means that the candy with flavor 2 is encountered for the first time, so I'll say number of unique candies plus plus. When I will be here, I will say count of 2 plus plus, so count of 2 will become 2. Now 2 means there is a flavored candy with flavor value 2 which was encountered before, so number of unique candies does not increase, so I do not increment this total count. Is this much clear? So now what I can do is, basically, first of all, I'll count the total number of unique candies among all n candies. Okay. Then I will loop over the first k candies and decrease their count and store my answer equal to total count. Okay, so basically I'll decrease the count of the first k candies and respectively update the total variable, and then my answer equals to total. So if I give away first k candies to the winner, what will be the number of unique candies with the geek? That is my answer. Now I'll slide this window of size k to the right by one step. Okay, so what I'll do, this is my array. I'll say now I am considering this k candies starting from index 2 to index k plus 1. So basically I'll increase the count of this candy because this candy is now with the geek, and I'll decrease the count of the k plus 1th candy because now this candy is with the winner. And on decreasing and increasing, if while decreasing the count of k plus 1th candy, if that count goes to 0, it means I have to do total minus minus because number of unique candies with the geek has reduced. And if while incrementing the count of this candy, if it counts become 1, it means I have to do total plus plus because the number of unique candies with the geek has increased. Is the concept clear? Then I will go to the window starting from third index to k plus 2th index. Then so I'll decrease increase the count of this candy and decrease the count of this candy. Then I will go on to the next window of size k and so on up till I reach to the last window. Is everything clear? Shall we move on to the implementation? Is this clear? Please let me know. Okay, great. Now, one thing to understand here is that the flavors of candies value can go up till 10 ki power 9. Since the flavor values can go up till 10 ki power 9, I cannot take an array to store the flavor values because if I declare an array of size greater than 10 ki power 6, that will give me a segmentation error. So what I have done is I have taken an unordered map of integers in which basically I will be storing the count of that candy. Okay, so basically mp1 of 3 will give me the count. If it is 5, it means candies with flavor value 3 are 5 in numbers present in my array. Okay, there are 5 candies in my array with flavor 3. Then I have taken variables I, j, n is equal to candy size. I total will store the total number of unique candies. Okay, this mp and unique will not be used. I think while I was solving, I have taken these extra variables because I was thinking of some other idea, but later on they were not used, and I have taken answer equal to 0 initially. Now, first of all, I want to count the total number of unique candies. So for I equals to 0 to n, first of all, I will check if my ith candy is present in the map or not. If it is present, then it has occurred before, so it will not increment the count of unique candies. So if map1 dot find candies of I, this will basically find whether the ith candy is present in map 1 is equals to mp1 dot end. So basically it will return an iterator to candies of I value, but if it is equal to mp1 dot end, it means this has not occurred before. So I'll say mp1 of candies of I equals to 1. This is the first time I am encountering a candy with flavor candies of I, and so my total number of unique candies will increase. Else I'll just simply increment the count of that candy. Okay, then what I have done, first of all, I have considered the first k candies to be given to the winner in the base case. So for I equals to 0, I is less than k, I plus plus, map of candies of I minus minus. If the count of any flavored candies goes to 0, it means now this candy is not available with the geek. So the total number of unique candies available with the geek will become minus minus. and I have stored answer equals to total. So what does this denote? This denotes the answer when I give the first k candies to the winner. Now I am sliding my window, so I am adding, so I index I means that index is added to the window. So starting from ith index, I equals to k, I is less than n, I plus plus. First of all, I am adding the ith candy to my window, to the winner list. Okay, so the count of that candy will decrease. So mp1 of candies of I minus minus. Also, I minus kth candy will be removed from the window of size k, so it will again go back to geek, so its count will increase. So mp1 of candies of I minus k plus plus. Okay, if mp1 of candies of I becomes 0 after doing subtraction, it means that uh, its count has become 0, so there are no candies with flavor candies of I with the geek. So I'll say total number of unique candies minus minus. If after adding the I minus kth candy to the geeks list, if the count of that becomes 1, it means it has occurred for the first time, or it is the only candy. So I have to increase the total unique candies with the geek, so I have said total plus plus. And at every step I am saying answer equal to max of answer comma total. Okay, so at every step I'll consider the ith candy to be given to the winner and I minus kth candy to be again given back to the geek. So my window will keep sliding. Okay, k size window. So if I give the ith candy to the winner, its count will decrease. If I give away the ith minus kth candy to the geek again back, its count will increase. If the count becomes 0, number of unique candies will decrease. If the count becomes 1 of I minus kth candy, then the number of unique candies flavors will increase. And at every step compare the answer with the total number of unique candies. Okay, is everything clear? Great. So let's move on to the last question. Okay, fourth place. Yeah, sure. So let's move on to the last array, stable array. What does this question say? Given an array A of length n, you have to make the array stable. Okay, so we need to make the array stable. Now, what is the definition of stable array here? A array is called stable when there exists a number x such that every number from the array occurs only x number of times or zero number of times. The task is to find the minimum number that needs to be deleted, that needs to be removed to make the array stable. So what they are trying to say is, they are saying that we are given an array, okay, and we need to make this array stable. Okay, now what is the definition of stable array? It says that the definition of stable array is that there exists some integer x such that the count of every element in the array is equal to x, or it is 0, so it does not occur. Okay, so let's say 2 2, 3 3, 4 4. Is this array stable? Yes, because 2 occurs 2 times, 3 occurs 2 times, 4 occurs 2 times. So x is equals to 2 and other elements are 0. There are no other elements. So the frequency of each element should be equal. It can be anything. Okay, it can be 2 2 2, 3 1 3 1 1 3. This is also stable. Okay, because the count of frequency of occurrence of each element is 3. 1 2 2 2 1. Is this stable? No. Why? Because 1 is occurring 2 times but 2 is occurring 3 times. Okay, or the count of all the elements are not equal, so this array is not stable. So we are given an array and we want to convert it into stable array. How can we convert it into stable array? By removing some elements. Okay, by removing some elements from the array. Now, if we remove some elements, we are asked what are the minimum number of elements to be removed. That is what we need to tell. Okay, what are the minimum number of elements to be removed to make the array stable? Is the question clear? Ashwath is saying I got first place in the contest. Congratulations, Ashwath. Okay, question is clear. Okay. So now understand one thing. First of all, you need to understand one statement that x in optimum case, x in optimal case. What is optimal case? When we delete the minimum number of elements from the array. What is x? The frequency of all the elements in the final array, which should be equal to x. Okay, all of them should be equal. So x in optimal case should be equal to frequency of some element of the array. Now I'll tell you why. See, understand one thing. Let us say the frequency, there are 5 unique elements in the array. Okay, the frequency of the first element is f1, the frequency of the second element is f2, the frequency of the third element is f3, the frequency of the fourth element is f4, and the frequency of fifth element is f5. Okay, let us say my x is equals to f 22, where f22 is greater than f2 and f22 is greater than f1. Okay, and my f22 is less than f3, f4 and f5. Okay, so understand one thing, since my f1 is less than f22, let us say x is equals to 5 and my f1 is 3, that is the frequency of first element is 3 and I want to make the frequency of all elements equal to 5 or 0. So in that case, I need to delete all these 3 elements because I have only one operation to do, that is remove elements. I cannot increase the frequency of that element from 3 to 5. I need to make it equal to 0, right? So I'll say my answer is equals to f1 because I'll remove these elements. Okay, plus similarly, since f2 is f2 is less than f22, I also cannot make it equal to f22, so I'll remove all the elements. So my answer is plus f2. Plus, now since f3, f4 and f5 are greater than f2, we will decrease their count till f2. Are you getting my point? So for example, if my f22 is 5, if my f3 is 7, so the frequency of the third unique element is 7. Now I have two choice, either to make this frequency equal to 0 or to make the frequency equal to 5. Here I need to remove 7 elements, here I need to remove 2 elements, so this is better. So what I'll do, for all the elements whose frequency is greater than the x, I'll convert their frequency up till x. Okay, so for third element, number of removal will be equal to f3 minus f22, because if f3 is 7 and f22 that is x is 5, I need to remove 2 elements. Similarly, plus f4 minus f22 plus f5 minus f22. Is this much clear? So now what I said, that x in optimal case should be equal to the frequency of some element of the array. Now why I said that? See, if I draw on the number line, let us say my f1 is here, my f2 is here, my f22 is here, my f3 is here, f4 is here, and my f5 is here. Okay, so my answer consists of f1 plus f2 plus this difference and this difference, right? But what could I have done was, let us take x is equals to f3. Okay, so in that case, see, f3 is greater than f1 and f2, right? So my answer will be equal to f1 plus f2, because since f3 is greater than f1 and f2, I cannot increase the frequency of first and second element to f3. I need to decrease them to 0 only. So these many operations I have to do, I need to remove these many elements. But for third element, I will need to remove 0 elements, because it will be f3 minus f3. For fourth element, I will remove f4 minus f3 elements, and for fifth element, I will remove f5 minus f3 elements. So for third element, I will remove 0. For fourth element I will remove these many elements, and for fifth element I will remove these many elements. So for first my answer would be f1 plus f2, which is common in both, right? And in the first case, my other than f1 plus f2, my answer was this and this, and in the second case my answer is this and this only. Are you getting my point? So instead of taking f22, I could have taken x equal to f3. That will reduce the number of operations to be done. Are you getting my point? Similarly, if let's say this is f1, this is f2, this is f3, this is f4, this is f5. Okay. Similarly, let's say someone tells f33 from here. So instead of f33 to be made equal to x, a better option would be to make f4 equal to x. Okay. Similar to the above example. So is the concept clear? First of all, that x in optimal case should be equal to the frequency of some element of the array. Other people? Hello, please give response so that I know whether to proceed further or not. uh, Other people, can I get some more yes? One or two? Hello. Okay, great. Okay, so what is x? X is the frequency of all the elements in the final array after removing some elements, because I want the frequency of all the elements to be same in the final array. Okay, so now x will be equal to frequency of one of the elements of the array. Okay, so what I can do is, first of all, if my array is 1 2 2 1 3, instead of this, what I can store, I can store 2 2 and 1. What is 2 2 and 1? 2 is the frequency of 2, another 2 is the frequency of 2, and another frequency 1 is the frequency of 3. Because as I said, if I have frequency count of each element, I can form an equation which will solve my question. Okay, so the first task is to make a new array which will store the frequency of each element. Okay, now I will sort that array. Why? Let me tell you. So let us say I have made a frequency array. Okay, so the frequency array is, let's say, 2 3 5 6 and 7. Okay, now understand one thing. What I said, x will be equal to any of the frequencies of the element. Okay, in the optimal case, so your x can be equal to 2 or 3 or 5 or 6 or 7. These are the frequencies of elements. Okay, please don't get confused. So my array would be something like this: 1 1 2 2 2, then let's say 3 3 3 3 3, 4 4 4 4 4 4, and 9 9 9 9 9 9 and 9. Okay, so this is 7 frequency, this is 6, this is 5, this is 3, and this is 2. Okay, now finally my x would be either of this. Let us take x is equals to 2. Okay, if my x is equals to 2, what will be the number of operations I need to do? So first element has frequency 2 only, so I do not need to do any operation. If my x is 2, I need to remove one element from here. I need to remove 3 elements from 5. I need to remove 4 elements from here to make its frequency 2, and I need to remove 5 elements from here. So the number of operations will be 1 plus 3 plus 4 plus 5, that is nothing but how much? 13, right? So if x is 2, number of operations will be 13. If my x is 3, then the number of operations will be how much? See, here it is 2. I cannot make 2 equal to 3. So I need to remove both elements. In the second element, I will not remove anything. Third element, I need to remove 2 elements. Fourth, I need to remove 3 elements. Fifth, I need to remove 4 elements. So this will be 4 plus 4, 8 plus 3, 11 number of operations. If my x is equals to 5, then my answer would be first 2 elements both I will have to remove, then the second 3 elements I also need to remove, the element which is frequency 5 I do not need to remove, the element which is frequency 6 I need to remove one element, and the element which is frequency 7 I need to remove 2 elements. Okay, so the total number of operations will be 3 plus 2, 5 plus 2, 7 and 1, 8. Okay, if my x is equals to 6, then I need to remove first 2 elements with frequency 2, that is this 1 1, because I want to make the frequency of all the elements equal to 6. So 2 plus, I also need to remove all these 3 2's, so 3 plus I also need to remove these 5 3's because I cannot increment their count to 6, plus this count is 6 only, so I will make it as it is, plus here there are 7 9's, so I need to remove one of them. Okay, so the count would be 5 plus 3, 8 plus 2, 10 and 1, 11. So if my x is 6, my number of operations will be 11. If my x is 7, then what would be the number of operations? If x is 7, then first 2 elements I need to remove, which is frequency 2. The remaining, the other 3 elements also I need to remove, which is frequency 3. I also need to remove 5 elements, which is frequency 5. I also need to remove 6 elements, that is this 4 fours, because I want the frequency of all the elements to be equal to 7. And in the last element, I will not remove anything. Okay, so it would be 5 plus 6, 11, 11 plus 5, 16. So here the number of operations will be equal to 16. What are we seeing? It decreased first and then increased first. Okay, so what I'm trying to tell is, if you sort the frequency array in increasing order, if you sort the frequency array in increasing order, then after choosing x, okay, if you choose x equals to f of I, so if you plot x, or if you plot x with the number of operations which you need to do, and if your frequency is shorted, okay, so this is f1, this is f2, this is f3, this is f4, these are all in shorted order, this is f5, this is f6, you will get something like this graph. Are you getting my point? So now what we can do is, we can apply binary search. Okay, so let's say your graph is something like this. Okay, let's say it can be like this. Basically it would be a bowl shape. Okay, so it can be like this, it can be like this also, it can be anything. Okay, so we need to find this point. So what I can do is, I can apply binary search. Okay, now so what will happen so if this is my graph, so this will be my starting point L, and this will be my ending point H. Okay, I will start with this L and I will start with this H. So first of all, as we do in binary search, I will take L plus H by 2 equals to midpoint and count the number of operations for midpoint. Okay, so let us say the midpoint is somewhere here. Okay, so after counting the number of operations for midpoint, I will count the number of operations for midpoint plus 1, and I will count the number of operations for midpoint minus 1. Are you getting my point? Then I will compare the number of operations of midpoint with midpoint minus 1 and midpoint minus plus 1. Okay, there can be 3 cases. First is, the number of operations of midpoint minus 1 is less than number of operations of midpoint is less than number of operations of midpoint plus 1. Other cases, number of operations of midpoint minus 1 is greater than number of operations of midpoint is greater than number of operations of midpoint plus 1. And the third case would be, number of operations of midpoint minus 1 is greater than number of operations of midpoint, which is greater less than number of operations of midpoint plus 1. This would be our optimal answer. In this case, the number of operations of midpoint is greater than midpoint minus 1, so we will do binary search on the left part. In this case, number of operations of midpoint is greater than number of operations of midpoint plus 1. So we will do binary search on the right part, and when we will get this condition, this will be the optimal bottom point. Okay, so this will be our answer. Now here in the starting, if I got this as the midpoint, then I will calculate for m minus 1 and m plus 1. Okay, so what I'll do, I'll say that okay, your m minus 1 has less number of operations, so I'll do binary search on the left part. So my L will remain this only, but my H will become this, equal to midpoint. Okay, now for this L and H, let us say the midpoint is somewhere here. Okay, so I'll calculate for midpoint, I'll calculate for midpoint plus 1, and I'll calculate for midpoint minus 1. Obviously midpoint plus 1 has the minimum number of operations, so I'll do binary search on the right hand side part. So this will become my m, this will become my L, and this will remain H only. So now this and this is what I'm under consideration. Now the midpoint for this L and H is, let's say, this. Now this is the lowest point, so we have got our answer. So in this way we will do binary search either on the left part or on the right part. Is this clear? There is also one small more concept which I need to understand for implementation. Okay, it's a very tricky part. Can we use the ceil value of medium value of the frequency of array to find x? I am not sure, but let us take one example which may counter it. Okay, so let us take, so in order to counter that, what I'm thinking is that I will choose a median which will be quite farther away from other points. Okay, but then again these values would be added. That might work. In this example also we got 5 as the lowest point, right, which was median. Okay, that is a good approach. I'm not sure about that, we need to think about it, but it should work, I think. Or let us take the frequency as 1 2 let us take equals to 4, or let us take it equal to 10 11 and 12. So for 10, number of operations would be how much? It would be equal to 1 plus 2 plus 0 plus 1 plus 2. That is nothing but 6. For 2, obviously the operations would be very high. For operations of 11, it would be how much? It would be 1 plus 2 plus 1 plus 0 plus 1. So that would be 2 plus 1, 3 plus 1, 4 plus 1, 5. No, here we are getting minimum number of operations for 11. We are not getting it for 10. So that will not work. Okay, taking the median value as x will not work. This is the example which you can see here. Oh, sorry, here the number of operations would be 10, right? It would not be 1, because we can't convert 10 to 11. So 1 plus 2 plus 10 plus this will give me how much? 10 plus 2 12 plus 2 14. Okay, so here also the median is giving us the minimum value. Well, this should work. Okay, but I'm not guaranteeing it, I'm not sure about it. Okay, if you use the median value, then your implementation will become quite easy. But the question is, will the median value work when you have uh, elements which are repeated again and again? That is what my question is. So let us say you have values 1 1 1 1 1. These are the frequency values. Okay, and let's say you have 2 and 2. So your median would be 1. If you take 1, the number of operations would be, you need to decrease 1 from this. So that will become how much? Or let's say here there is 10 and 10. Okay. So now your median is 1. Okay. So if you take median as 1, then the number of operations would be 0 plus 0 plus 0 plus 0 plus 0 plus 9 plus 9, which is equal to 18. But if you take 10, then the number of operations would be how much? 1 plus 1 plus 1 plus 1 plus 1 plus 0 plus 0. That is equal to 5. So in this case, where the frequency values are getting repeated, in that case, your median value will not work. Is this clear? Is this clear? Okay, no problem. You are welcome. So what we have understood is, first of all, we will store the frequencies of each element of the array, then we will sort it, then we will apply x would be equal to one of the frequencies, and then we will apply binary search on the frequency array and we will find the minimum. Okay, now if we select x is equals to f of I, we know how to calculate the number of operations, right? We can calculate it using the formulas here we have taken 4 5 examples. Okay, it would be, let's say x is f3, then my answer would be equal to f1 plus f2 plus f3 minus f3 plus f4 minus f3 plus f5 minus f3. Okay, so now one more thing which we need to understand is to tackle this kind of things. Okay, so if my array is 1 1 1 1 1 10 10, this is my frequency array. Okay, so implementation also we understood, but that can be a small twist. That's why I'm telling you. Okay, here how many elements are there? 7 elements. So your L is 0 and H is 6 initially. Yes, नहीं बाकी है, क्लास चल रही है 15 मिनट बाद. Sorry. Can't I practice of the contest? Yes, definitely you can practice the question of the contest after it gets over. You can go to the contest link, then go to the weekly coding contest and then solve it. Okay, sorry for the disturbance. Now let's continue. So if my frequency array is this, then here what will happen? Your m will be equal to L plus h by 2, which will be equal to 3. So third index is this. Okay, now the frequency, the number of operations, if you take x is equals to 1, what I said, we will calculate for m, we will calculate for m plus 1, and we will calculate for m minus 1, and wherever it is going low, we will go there. Now in this case, here this will also give the same count, this will also give the same count, and this will also give the same count. So you do not know where to go, left or right. Are you getting my point? So what we will do is, after storing and sorting the frequency array, we will form one more array. So let's say your frequency array is 1 1 1 1 2 2 2 3 3 4 4 4 4. So I will form one more array which will store the frequency count. Please hear this clearly. It will store elements in pair. So it will store frequency count as the first element and the number of elements with that frequency as the second element. So let me call it F1. So this will store what? This will store 1 comma 4, which means number of elements whose frequency is 1 are 4 in the array. Okay, then 2 3, number of elements whose frequency is 2 are 3 in the array. Then 3 3, number of elements whose frequency is 3 are 3 in the array. Then 4 4, sorry, not 3 3, 3 2, there are 2 elements in the array whose frequency is 3. Then 4 4, number of elements whose frequency is 4 are 4 in the array. Is this clear? Please let me know, then we will move further. Now here there will be no 2 consecutive same elements. We were having issue while applying binary search on this, because here we were not able to decide whether to go on the left part or on the right part. Are you getting my point? But here there are no two consecutive elements will have the same value, right? Is this clear? Please let me know in the comments, then we'll go further. Now only a very simple part is left. Hello, is this clear? Okay, great. So let's move further. So please like the video if you are enjoying this or if you are understanding this. Okay, so now we will apply binary search on this. So our x could be either 1 or 2 or 3 or 4. Okay, suppose my x is equals to 2, that is equals to f2. Okay, frequency of second element. So now how will we calculate the total number of operations? We will say for all the elements which have less frequency than 2, we need to remove all of them because we cannot increase their frequency to 2. So my answer would be equal to 1 into 4 because I need to remove all the elements who have frequency 1. So total how many elements will be removed? Number of elements are 4 and each has frequency 1. So 4 into 1 plus there are three elements whose frequency is 2. So 3 into 2 minus 2 plus. Now there are two elements whose frequency is 3. So 3 minus 2 plus there are four elements whose frequency is 4. So 4 minus 2. So the number of operations if my x is 2 will be equal to 4 plus 0 plus 2 plus 8, which will be nothing but equal to 14. Is this clear? Now let's move on to the implementation part. Okay, let me make it full screen. Okay, so I hope this is visible. So what I have done is, see, I have taken one vector b in which I will store the frequencies and sort them. I have taken one vector c in which I will store the frequency and the number of elements whose frequency is that. Are you getting my point? The last array of pairs which I showed. Okay, then I have taken n equals to a dot size. Initially I have taken answer equals to n because the maximum number of elements which you will remove is n. In the worst case, obviously that would not be the answer, but since I want to form the equation answer equal to mean of answer comma operations, so I have taken initially answer equals to n. Now I want to count the frequency. First of all, I have sorted the array. Okay, so similar elements will be together. So what I have said is, for I equal to 0, I is less than n. First of all, make j equals to I. Now j will remain constant. Okay, and we will increment I till what time? Till we get the same element as j. So while I is less than n and a of I equals to a of j, so we are getting the same element, increment I plus plus. Okay, so the element which was at jth index, its frequency would be how much? I minus j. When it will not be repeated, at that time we will come out of the while loop. So the frequency of that element would be equal to I minus j. So I will push that into my array b. Okay, now I have shorted the taken n is equals to b dot size. B is my frequency array and I have shorted the array. Okay, now again, for frequency array, I need to store, let's say frequency of 3 is repeated 4 times. So I need to store 3 comma 4 as a pair. Okay, so again I have done the same thing which I was doing here, but here these were elements, these are frequencies. Okay, so for I equals to 0, I is less than n, j equals to I, while I is less than n and b of I equals to b of j, I plus plus. Okay, So basically, when we will come out of the while loop, so the frequency, the number of elements whose frequency equals to b of j will be how much? I minus j. And I want to store them pairwise. So c dot push back b of j, that is the frequency count, and the number of elements whose frequency count is b of j is how much? I minus j. Okay. So now we have got the final array on which we can do binary search. So I have changed n equals to c dot size. I have called a binary search function where lower index is 0, final index is n. I have passed the C array, I have passed the answer variable, and I have passed the size of the array C. Okay. So this is my binary search function. If so, first of all, tell me, is this clear? Then we will look at the binary search function. Is this clear? Forming array B's and C's, right? Okay, great. So let's look at the binary search function. So what I have done is, if L is less than equal to H, first of all calculate mid M equals to L plus H by 2, M1 and M2. Okay. Int ij d equals to 0. D will count the number of operations for considering x equals to b of m. B of m is the frequency of the frequency count of the element at mth index. Okay. And then d1 and d2 I have used for left and right part, but further we will see we will use only one. We do not need to use both of them. Okay. So if I am considering x equals to c of m, okay, not b of m, so what will be the number of operations for I equals to 0, I is less than n, I plus plus, if c of I dot first is less than c of m dot first. So if the count of frequency of ith element is less than count of frequency of mth element, then I need to delete all of them. So that will add to my number of operations the number of frequency count, that is c of I dot first, and number of elements with that frequency, that is c of I dot second. Okay. So if there are three elements with frequency 2 and my x is 5, I need to delete all those three elements. All three elements have frequency 2, so total I need to delete 6 elements. That is what I am doing here. Else, if that is not the case, then d equals to d plus number of elements with such frequency multiplied by c of I minus c of m dot first. Okay. So if c of m dot first, that is x, is let's say 5, and if a particular frequency value is 7, I need to delete only two elements. So that is c of I dot first is 7 minus c of m dot first, that is 5. So 7 minus 5 will give me 2, multiplied by the number of elements with frequency c of I. So that is c of I dot second. Suppose there are three elements with frequency 7. So from each of them I need to delete two elements. So 7 minus 5, that is 2. 2 multiplied by 3, total 6 elements. Okay. So first of all, I will compare D with my answer. So answer equals to minimum of answer comma D. Please remember, I have passed answer as a reference here because I have declared it in the in that function. Okay, stable array. So I need to make changes in that value only. Okay. So now answer equals to mean of answer comma D. If L is less than M, now I want to check for M minus 1, but I can only check for it if my L is less than M. If L equals to M and I'm considering from L to H, I cannot consider on the left part. Okay. So if L is less than M, M1 equals to M minus 1. Okay. Now instead of M, just put M1 and calculate the value of number of operations. I have stored it in D1. Okay. If D1 is less than D, so if the number of operations required when I am considering M minus 1th element, then simply call binary search on the left part. Okay. Wherever there are less operations, call the binary search on that part. Okay. Also, if on M minus 1 the number of operations are less than M, then on M plus 1 it would be definitely greater because my graph is like this. Okay. So that's the first case. Another is if H is greater than M. So if there is some element on the right hand side, then only I can consider M plus 1. So again, I will use D1 and M1 only. Okay, now you understood. Here I took M2 and D2 also to consider on right side. but then later I realized I can use the same variables. So d1 is the number of operations and m1 is equals to m plus 1. Again, repeat the same loop to calculate the number of operations required when considering m plus 1th element as x. Okay, so you will use this formula and calculate total number of operations in d1. If d1 is less than d is the number of operations required considering m element as x. Okay, so if d1 is less than d, we need to do binary search on right side. So I'll call binary search m plus 1 h, c, answer, and n. And if both of these conditions are not there, we will not do anything. Okay, because then m is the lowest point. Okay, so our answer will keep updating, and finally we will return our answer from here. Okay, is this clear? Okay, so we have solved this problem successfully. Is this clear? Please let me know. Any doubts in this? Okay, great, Ashish. Athityan V, is this clear? Other people, there was also Ravi, I think, who was talking about last question. So is Ravi in the chat? Is this clear? Any doubts? So I hope all the four questions are clear. And if you like this video, please make sure you give it a like. And if you also like the explanation, you can take a screenshot of it and take a screenshot of the screen and share it on LinkedIn and tag me and Geeks for Geeks. Okay. Other people, is this clear? If you share it on LinkedIn, it will motivate us more to bring such solutions, good solutions. Okay, great. Okay, so if there are no doubts, I think we can end the live stream here. I hope all the four solutions were clear. Good night, take care, and see you next time.